Welcome to qnawire.
For this question, we have a very large flat conducting sheet of thickness T carrying a uniform current density J. Look at figure 56 if you want to get a visual representation of this. So we're going to determine the magnetic field at a distance y above the plane. So we're going to assume the plane is infinitely long and wide. So to do this, we're going to first consider what the current enclosed is. So we can say that we'll call this I sub E for I enclosed. And this is simply just equal to the current density J times the thickness T times the size of the length that we want to consider here, which is S, or the displacement of the current. So J times T times S would be I enclosed. So the net magnetic field from Ampere's law is going to be equal to, so we have the integral, and this is the integral of the side, so we'll call this the integral over side, is B dot ds. ds is the integration, what we're integrating over, plus we have the integral over the lengths here, also of the magnetic field, over ds. And using Ampere's law, this is going to be equal to mu naught times I enclosed. We call it I sub E for I enclosed. Or in other words, this is equal to mu naught times J times the thickness T times S, where again, S is the displacement of the current. Okay, so what do the integrals equal? Well, the integral of B dot ds is just B times S, because we're integrating from 0. The area is being integrated from 0 to S for both the side and the length. So we have B times S plus B times S is equal to mu naught times I enclosed, or mu naught times J times T times S. Or B times S times B times S is 2B times S, and this is equal to mu naught times J times T times S. Of course, the S's cancel. That's pretty easy to see. And we just want to solve for B. And what we end up with is B is equal to mu naught times J times T divided by 2. So that would be the magnitude. But it also asks for the direction. So using right-hand rule, we find the magnetic field is towards the left above the sheet. So we can also type out towards left above the sheet, and then right-hand rule. RHR just going to stand for right-hand rule, and that's how I determine that. You could also write out right-hand rule if your teacher doesn't like that shorthand notation. But we can go ahead and box this in as our solution for magnitude and direction of the magnetic field that we're asked to find.